This video is designed to help you understand how to sketch or graph from useful information a parabola. There are multiple ways to go about doing this, but we're going to look at generally what can happen when you graph a parabola and what the useful points are for doing so, and what to keep in mind when graphing a parabola. So the first thing is to recognize that you can do an input-output table for any equation. So if you had the equation, let's say y equals 3x squared plus 2x minus 10, you could simply do an input-output table, x and y's, and you could start plugging in x's and come up with y's. And this would allow you to eventually plot some points, and once you had done that, so for example, if we pick x is 0 to start with an easiest one, then y is negative 10. You could pick x is, let's say, 1, and we'll see what we get. That's going to be 3 times 1 squared, which is 3, plus 2 times 1, which is 2, so 5 minus 10, so it's negative 5. I'm just doing this on the fly, so there could be some errors here, but hopefully this will all work out. So if we picked x equals 2, then we're going to get 3 times 4, which is 12, plus 4 is 16, minus 10 is going to be 6. And you should also pick some negative x values, so negative 1, you're going to get 1 squared, negative 1 squared is 1, 3 times 1 is 3, plus 2 times negative 1, so that's going to be 3 minus 2 is 1 minus 10, which is going to be negative 9, and so on. And if you did this and plotted the points, let's just make a quick sketch. So we're going to get 0, negative 10, so that's going to be down here. We're going to get 1, negative 5, that's going to be here. We're going to get 2, 6, that's going to be up here. You're going to get negative 1, negative 9, so that's going to be down here. What that's telling us is we probably have a parabola that's definitely started back in the up direction, so I don't know, it's going to look something like this, and the vertex is going to be somewhere down in here. So the vertex is going to be somewhere in this area. It could be the negative 10, and but it actually isn't, or either side of 0 would give us the same value, since it's got to be symmetric. So what we actually know is that the axis of symmetry is somewhere around here, and it's a little bit to the left of x equals 1. And we're going to take advantage of that in the next slide and take a look at some examples. But you can always just plot some points and then sketch it out. If I were actually doing this one, I would plot a couple more points in the negative side just to get clear. So let's do one more. Let's do negative 2. 3 times negative 2 squared. Negative 2 squared is 4, so that's 12. Plus 2 times negative 2, so 12 minus 4 is 8, minus 10 is negative 2, so that's going to give us something in here, and so it looks like, you know, we've sketched it fairly well. Let's take a look at the next slide and see what steps we can use to really kind of hone in on doing this fairly quickly and take advantage of some of the skills we've developed in the last few chapters. So just as a quick reference, I've sketched 4 parabolas here, and it's worth noting, you know, what's going on in each of these cases. So in A, what we have is a parabola with an axis of symmetry, not necessarily on the y-axis. I've just simply shown that we have 3 points that we can find, and those 3 points are marked in red. And the 2 that correspond to the x-axis, where the parabola intersects the x-axis, are actually the roots when we solve for x. When we solve the equation y 0 equals ax squared plus bx plus c, we're going to get those 2 roots. And what we've sketched in these four cases, in case A, we have the classic case where we solve for x and we get two distinct roots. Remember, the opposite of b plus or minus square root of b squared minus 4ac all over 2a using our quadratic formula. What we have is the center line, whatever that would be the opposite of b over 2a, and then we're going to get the two roots, plus and minus the square root of b squared minus 4ac all over 2a, and those are going to be our two left and right dots. And they're going to be left and right of the center line. If this sketch, which it sort of looks like, had the y-axis as the center line, then those 2 points would be equidistant from the y-axis. But this would allow us to sketch 3 quick points to find the y-intercept and the two roots. And of course, as soon as we have the roots, we have also the center line, because halfway in between them is a value of x that tells us the center line. On sketch B, what we see is a parabola that just barely comes down and touches the x-axis and then takes off again. What that means is we only have one root, and that would be the vertex and therefore the center line. And what that's saying is the center line of this parabola is going to be somewhere in here. That was intended to be a dotted line, so let's try that again. Didn't work out all that well. But let me actually erase it, sorry about that. And so this would be the center line, and that's going to help you with plotting points and sketching it. If you find 1 or 2 points off to the side, for example, find the y-intercept as I've sketched there, and one other point, then you could follow points that are going to be equidistant from that center line. In other words, it should look the same on either side of the center line. Version C is the case where there are no real roots. What that means is when you solve using the quadratic formula, you're going to get negative numbers in the discriminant, in which case you don't have the roots. However, you're still going to get a center line, which you should be able to sketch, and that's going to tell you where the vertex is. You plug in that value of x and you'll get a value of y. So you should be able to identify this point fairly easily by plugging in the opposite of b over 2a. So this is going to have the value right here. This point is going to have the value for x, the opposite of b over 2a, and that's true for every vertex, and then whatever y's value is. So it's going to be y of opposite of b over 2a. Actually, that looks too much like I'm multiplying. So I was trying to use function notation, so let's not do that. Let's just say there will be a value of y, and we'll call it y sub v for a vertex. Okay, so you get that by plugging in the opposite of b over 2a. And then on D, just as a reminder, of course, you can have a parabola that is upside down. This is the case when a is negative in the y equals ax squared plus bx plus c. When a is negative, you're going to have an upside down parabola, and you'll have a vertex at the center line again. So let's move on to the next slide to see, take some specific examples. So here's an equation of a line, a parabola, y equals x squared plus 2x minus 5, so we have a quadratic. In this case, a is 1, b is 2, and c is negative 5. Having said that, we now know that the vertex, or at least the center line, we know the x value of the center line. So if we think about our quadratic formula, the value of the center line is when we have the opposite of b over 2a. This is the first part. And then, of course, it's plus and minus on either side of that in uniform amounts. So this is going to give us then the opposite of b is negative 2 all over 2 times 1. So that's 2. which means it's -1. So our center line is at the value x equals -1. So I'm going to write that as x sub c, x, the center line. And so if we sketch this, what we know immediately is that we have a center line at x equals -1. So I'm actually just going to draw that center line, which I'm not doing a very good job of. Let's try that again. I'm sure I have. Okay, and we're going to say that this is at the line x equals -1. Now what we need to do is find some other points. So let's actually find the roots, which means when we set y equal to 0, we're going to be solving for 0 and x squared plus 2x minus 5. Now, this doesn't actually factor nicely, so what we're going to need is to use is the quadratic formula. If it factored nicely, we'd get our roots right off the bat, but it doesn't. So we're going to need to do that. The versions of x are the opposite of 2 plus or minus the square root of b squared, which is 4, minus 4ac, so it's -5 for c, so it's going to be plus 4 times 1 times 5, which is going to be plus 20. So that's going to, and then all over 2a, and of course a is just 1. So that's going to give us x is -1 plus or minus root 24 over 2. Root 24 can be simplified to 2 root 6. So this is 2 root 6 over 2. And so that's going to give us our vertex, our roots at -1 plus and minus root 6. If we put that into a calculator, we know then the exact roots are going to be at -1 plus 6 and comma 0, and -1 minus 6 comma 0, root 6 comma 0. We can approximate those. If we do this, we're going to use -1 plus root 6, and that winds up being about approximately 1.4. We're just going to get some rough ideas here. So -1 plus root 6 is about 1.4, and -1 minus root 6 is about -3.4. So what that means is we're going to, and of course these are going to be plus or minus root 6 on either side of our center line. So that means is we're going to go root 6 in this direction, and that's going to be about 1.4. So somewhere in there, and -3.4, so maybe somewhere in here. And the point that I want to make is that this distance right here is the square root of 6. And this distance right here is the square root of 6. Remember, we're square root of 6 either side of -1. So those give us our roots, and we know that the vertex, of course, must be, I'm just going to circle an area, must be down in here somewhere, since this is since a is positive, which means it opens upward. So let's see if we can find that exact root, and what that means is we just need to plug x equals -1 in to the original equation, and if we do that, we're going to get y equals -1 squared, which is 1, plus 2 times -1, which is -2, and then -5, and so that's going to get us y at the vertex, so we'll call it y sub v. And of course this is x sub c, which we could also call x sub v for vertex, I suppose, but it's x sub c is our center line. And we're going to get y sub v is 1 minus 2 is -1, minus 5 is -6. And so what we know is that we have a point down here, and let's put it about Okay, let's put it on the lower end here. It's going to be somewhere around here, and that point, of course, is our vertex, which is at -1, comma, -6. And so we've got 3 points, nice and easy to sketch it. Just to get a little sense of the curvature, it would be nice to plot, let's say, the y-intercept, which means when x is 0. So that's another useful point to plot. So when x is 0, we're going to get the point 0, comma, let's not do it over there, that's kind of in the way. When x equals 0, let's see, when x equals 0, y is going to be -5, so we have the point 0, -5, so that's about here. So there's a point 0, -5, and that means there's another point on the other side right in here. It's going to be roughly the same, and we should be able to roughly sketch our parabola. Let's do this in red, and it's going to look something like this. Okay, and of course you could sketch it a little more accurately by throwing in some other points and using an input-output table. But here's a classic example of being able to use the roots and the center line to get your vertex, and 2 points on either side of that, which gives you a rough idea of how to sketch it out, and using the y-intercept to get a 4th point to kind of help with your curvature a little bit. Okay, I hope this has been helpful. Let's take a look at one other graph on the next slide, just for a quick one. Here's another example of a quadratic equation. Once again, just for the sake of little easier numbers and so forth, I've selected a as 1. Excuse me. Obviously, this all works using quadratic formula when a is any value. But what I wanted to do was get a quick sketch of this one. And the nice thing about this one is that it actually factors. So the one thing that I would start with again is picking x, the center line x. So I'm going to call it x sub c again, and that value is going to be the opposite of b, which in this case is +6, all over 2a, which is going to be 2, which means that the center line is when x equals 3. So if we have an x and y axis over here, we should be able to sketch a center line that's going to be x equals 3. So this graph, this is the center line, x sub c equals 3. And of course, let's get the vertex this time right off the bat. And that means when we plug in 3 for x, so what we're going to get if we do that is we're going to get 3 comma. Plugging in x is 3, we're going to get 9 minus 18. So 9 minus 18 is -9 plus 8. So that's going to get us -1 if I've done that correctly. See, 3, yeah, okay, so 3, -1. So what that means is we have a vertex of 3, -1. So that's going to be somewhere in here for our vertex. So that's going to be at 3, -1. And this one, of course, opens upward since a is +1. And now what we need to do is get our roots. And so nicely, this problem factors. And we should be able to get, when we set y equal to 0, what we're doing is we're saying, where does it intersect the y-axis? So somewhere on this, the x-axis, excuse me. So when y is 0, of course, it's not off the x-axis. We're just going to get the values of x, which are the roots we've been solving for when we've been factoring. We're going to get the values of x that allow us to graph the x-axis intercept. So what we're going to get is x and x again, and of course 8 factors into 4 and 2, and those are going to add up to 6, and they're both negative like that. So what we're going to get is x equals 2 and x equals 4 are our roots, and so those correspond to the points 2, 0 and 4, 0. So I think it's important to recognize and claim those points. So 2, 0 is going to be somewhere in here, and 4, 0 is going to be somewhere in here. And what we've done then is we've come up with our rough parabola. And before we finish off the left side, let's come up with the y-intercept as well. In other words, when x is 0, so we're actually going to get the point. So when x equals 0, y equals 8, of course, and that's fairly easy to come up with. So there is another point that we can sketch, 0, 8. Let's see, that's going to be 0, 8. That's going to be somewhere up in here. And that's going to fit fairly well with what we've sketched. So this is 0, 8. And let's finish sketching the other side of this parabola. And so it's going to look something like that. And off it goes. And this one in that direction. So once again, using the center line, the two roots, if they exist, and the y-intercept allows us to do this. If not, if it doesn't intersect the x-axis and you can't find any roots, in other words, when the discriminant is negative, then a lot of times you just want to do some input-output, but you can certainly find the center line using the opposite of b over 2a every single time. And once you find the center line of the parabola, it's fairly easy to sketch a few more points. So finding the center line first is a great idea. And then go, take some x values on equidistant from that center line. So if the center line was, let's say, well, in this case, 3, then go, 2 and 4, 1 and 5, and so forth. Go either side of it, because every point on this parabola, this distance and this distance are the same. I'm going to just call those A and A. And everywhere you go, for every value of y, the two values of x are equal and opposite around that, opposite distance around that. So they're always going to be the same distance away from from that center line. So I hope this has been helpful.